Okay, today we're going to talk about graphing linear equations. So the first thing is a solution. The solution of a linear equation is an ordered pair that makes it true. Okay, and what we cannot forget is that ordered pairs always go x first and then y. So if you look down here at example number 1, it says determine whether each ordered pair is a solution of y equals x plus 10. So in this first ordered pair, x is 3 and y is 1. So we're going to plug it in to see, well, does the y equal x plus 10? So in this case, the y is 1 and x is 3 plus 10. I kind of ran out of room. So does 1 equal 13? No, that did not make a true statement. So our answer is no. Okay, let's look at this next one. Okay, again, it's x and y. So does the y equal the x, plus 10? That should be an x. The y is 13. Does that equal 3 plus 10? Well, 3 plus 10 is 13. So does 13 equal 13? Is that a true statement? Yes. So the ordered pair 3, 13 is a solution. Okay, and then we're going to check this last one, y equals x plus 10. So the y is 5, the x is negative 5 plus 10. So does 5 equal, these are different signs, subtract. So 10 minus 5 is 5. Keep the sign of the bigger number, it's positive. So does 5 equal 5? Yes. So the point negative 5, 5 is a solution of this equation. Okay, let's look together at number 2. Okay, we're going to do the same process, but this time our equation is y equals 2x minus 5. Okay, so does y equal 2 times x minus 5? So in this case, our x is 2 and our y is negative 1. So does negative 1 equal 2 times 2 minus 5? So does negative 1 equal 4 minus 5? What's 4 minus 5? Negative 1. So negative 1 equals negative 1, so that's yes. Okay, and then this middle one, does y equal 2 times x minus 5? I put 7's in for both because 7 was x and y. So does 7 equal 14 minus 5? Right, 14 minus 5 is 9. Does 7 equal 9? No. Okay, and then this last one, I have, does y equal 2 times 0, because 0 is x, minus 5. So that would give me 5 equals 0 minus 5, which is negative 5. Does 5 equal negative 5? No. Okay, then on number 3, it says use the equation y equals 3x minus 2, complete each solution. Okay, so which one is this? Is that x or y? I'm given x, and I want to figure out what y is. So if I put a 5 in here for x, right? It's y equals 3 times x minus 2. So y equals 3 times 5, which is 15, minus 2. 15 minus 2 is 13. So I put a 13 in there for the solution. Okay, on this next one, y equals 3 times x minus 2. So y equals 3 times 10 minus 2. So what's 30 minus 2? 28. And I put that in there. And then this last one, y is equal to 3 times x, which is 1, minus 2. So y equals 3 minus 2. So y equals 1. So 1, 1 would be my solution. Okay, and then this last set of examples say, on which of the following lines does each point lie? A point may lie on more than one line. Okay, so let's look at this right here, 1, 6. And I want to see, does it work for part A, right? A is y equals x plus 5. So if I plug in 1 and 6, does it make it true? So does 6 equal 1 plus 5? Yes. So A works. Okay, let's plug in b. So for b, I have y equals 2 times x minus 1. And again, this is my x, this is my y. So does 6 equal 2 times 1 minus 1? Does 6 equal 2 minus 1? No. So it does not work for line B. And then we can check line C, which is y equals negative x plus 7 down here. So I want to see, well, does this point, is it a solution of this equation? So does 6 equal negative x? So negative 1 plus 7. Their different signs subtract. 6 equals 6. So it does. So the answer to this one, we would say, would be A and C. It's a solution of A and C, because when I plugged it into A, it worked, and when I plugged it into C, it worked. So now we're going to do that same process for this ordered pair, negative 8, 15. So let's try out line A first. So does y equal x plus 5? So does 15 equal negative 8 plus 5? So negative 8 plus 5 would be negative 3. So does 15 equal negative 3? No. So it is not a solution of line A. Then let's check line B. That's y equals 2x minus 1. So does y equal 2 times negative 8 minus 1? So that's negative 16 minus 1. That's negative 17. Okay, so that would be no. Oh, hello, Miss McNally. Because the y was 15. And 15 doesn't equal negative 17. And then let's check C. So I have y equals negative x plus 7. So y is 15 equals negative x. Well, x is already negative, so what's negative times negative? Positive. So does 15 equal 8 plus 7? Yes. So this one only has one solution, and it's C. It only worked when we plugged it in to line C. Okay, so now turn your notes over, and we're going to graph these linear equations. We get to pick whatever numbers we want for x. We're going to plug them in, work them out, and then we're going to graph our points. So let me get a few other colors out here. There we go. Okay, so let's say that I'm going to pick 2 for x. Okay, then I'm going to plug it in. 2 times 2 is 4, plus 1 is 5. So that gives me the ordered pair 2, 5. When I put in a 2 for x, I got out 1, 2, 3, 4, 5 for y. Okay, so now let's try a different number. Let's try 0. 0 is always a good one to pick. 2 times 0 is 0. 0 plus 1 is 1. So when I put in a 0, I got a 1 for y. So I graph the point 0, 1. Okay, now let's try a negative. Let's try negative 2. So 2 times negative 2 is negative 4, plus 1 is negative 3. Negative 2, negative 3. Okay, and then, I mean, you could literally pick any number. Let's just pick 1. That's an easy one. 2 times 1 is 2, plus 1 is 3. So I have the point 1, 3. Oh, 1, 2, 3, 4. Y'all, I messed up on that green dot. This is 5. There we go. Okay, so now that we have all our dots, we can connect them with a line. Okay, and look, they made a perfectly straight line. And watch what's going to happen if I pick any other number. I could even pick, let's say, negative 3. 2 times negative 3 is negative 6, plus 1 is negative 5. So look, negative 3, negative 1, 2, 3, 4, 5. Isn't that cool? It will work every single time. Okay, now, you can pick whatever numbers that you want. I would avoid picking giant numbers like 10 because let's think about it. That's going to give me 20 plus 1 is 21. Do I want to graph 10, 21? No. So I want to make sure I kind of am keeping my points in my graph. Okay, and on that note, look at number 5, where we have negative 1/2 of x. Okay, I'm going to start with an easy one. I'm going to start with 0, because what's half of 0? Half of 0 is 0. 0 plus 3 is 3. So I have the point 0, 3. Easy. Okay, if I pick a number like 1, I'm going to have to do -1/2 times 1 is -1/2. Actually, let's work it out. If I put in 1, -1/2 times 1 is -1/2, plus 3 would be 2.5. And I'm going to have the point 1, 2.5. Okay, which is fine, but I would rather not have to deal with decimals and graphing things in between and all of that. So I'm going to pick multiples of 2. Okay, that's like 2, 4, 6, 8. Because, look, if I pick the number 4, what's half of 4? It's 2, and then it's -1/2 of 4, so that's -2 plus 3 is 1. So 1, 2, 3, 4, 1. Okay, then I could plug in, I could even do, let's do -2. What's a negative times a negative? It's a positive. So that would be +1 plus 3 is 4. So I have the point -2, +4. Okay, and so I'm going to connect these with a line. And there we go. And again, let's say I had picked the number 3. -1/2 times 3 is -1.5, plus 3 is 1.5. Here's the point 3, 1.5. Okay, and then the last one, number 5, I'm going to pick my x values. So I'm going to start with 0, because again, that's easy. -0 is 0, plus 1 is 1. 0, 1. Then I'm going to pick 2. So it's not just 2, it's the opposite of, right? It's -x. So if x is 2, that's -2 plus 1 is -1. So there's the point 2, -1. What if I pick an actual negative, like -3? So if I plug this in here, what's the opposite of -3? +3, right? It's negative, which is positive. And then 3 plus 1 is 4. So when I put in -3 for x, I got out 4 for y. Okay, and then if I put in +1, that would give me the opposite of 1 is -1, plus 1 is 0. Oh, I forgot to write this. So I have the point 1, 0, and then I'm going to pick -2. So -2 is 2, plus 1 is 3. So here's the point, -2, 3. And then I'm just going to take my pen, I'm going to connect them in order, and there you go. If you are getting a janky dot, like let's say you did one and it was like way out here, okay, then you messed up the math on that point, because every single time it will make a straight line. And if it's not, more than likely you made an error on your negatives. So just double check this.